Let's look at nuclear reactions. So before, I want to introduce the nuclear particles, right? I.e. the molecules in chemical reactions. So these are the players that you'll see in nuclear reactions. This table is in your textbook. So go look at this table in the textbook, right? Read the section before, the paragraph before and after. Read the section where this table is, okay? And then read it and then be like, do I feel like I know what a nuclear particle is? Do I feel like I understand what nuclear particles are? Just that simple question. If it's yes, done. If it's no, figure out the next step, okay? So we've got alpha particles, beta particles, positron, proton, neutron, gamma ray. These are the symbols, so this is how we will write it in a nuclear reaction. And this is just a representation of those particles, right? So with an alpha particle, it's a helium nuclei that has 2 protons and 2 neutrons. So that's what this representation is. It's representing the 2 neutrons, which are these gray balls, and then it's representing the 2 protons, which have a positive charge, right? Because protons are positively charged. So, play. Can you think of another way to represent it? This is the representation that's presented to you, but maybe you have a better representation that will work for you to represent an alpha particle. So maybe once you read that section, be like, all right, I'm going to draw my own representation of all the particles. This is why I make y'all draw things, right? Because if you come up with your own drawing, then it's like a great way to assess if you understand it. But if you have no idea where to even start to draw, that might be an indication that I have no, like, I don't get the main big picture of this concept, right? Maybe you all have an idea of what to draw, but if you draw it and there's like some inaccuracy in it, then that lets you know where your holes are in that concept. So just play around with that. Each thing that I'm talking about, this section, see if you can make a drawing for it. And if you can't, or if you notice it's a struggle, ask, what is this telling me about what I need to learn? Where is this pointing me to? So try it. Let me know how it goes. All right. So back to nuclear particles. So these are all the particles that will be in our nuclear reactions. So these reactions, right, they follow the conservation laws, right? Same thing, energy cannot be destroyed or created here. Those same laws that govern chemical reactions are governing our nuclear reactions here, right? They're balanced in 2 ways. So the sum of the mass numbers in the reactants equals the sum of those in the products, right? The sum of the charges of the reactants equals the sum of the charges of the products. So with chemical reactions, we were balancing the elements, making sure we had the same amount of elements on both the reactant and product side. Here, you're looking at the sum of the mass numbers and the sum of the charges should be equal on both sides. And that lets us know that it's balanced. Okay, so let's look at an example. We've got uranium-238, right? What does that even mean? Do you know what I'm saying when I say uranium-238? So this nuclide undergoes alpha decay. What new element forms? So this is how we would write the nuclear reaction. So first, this is how we note uranium-238. This lets us know we're talking about uranium-238, which is the element and its mass number. It undergoes alpha decay, so remember that slide before with the nuclear particles? These are the particles, right, that we'll see in a nuclear reaction. So alpha decay an alpha particle, right? It involves reacting with an alpha particle, which is helium. So this is our alpha particle. So we know that if it undergoes decay, that means that we're forming an alpha particle. And so now to balance this, we're asking, well, what did this alpha particle react with to form uranium? Or what did uranium decay into after undergoing alpha decay, right? So what did it decay into? Because remember, it's always going to form a new element. It's going to form a new element. So we're figuring out what is that element. So to figure that out, we use those two rules for balancing our nuclear reactions, right? The sum of the mass number must be the same and the sum of the charge must be the same. Well, the sum of the charge is the protons, because protons are positively charged and neutrons are not charged. So the atomic number tells us the charge. So let's look at our mass number first. We've got 238 on our reactant side. Well, what does A need to be to balance out our mass number of 238? So 4 plus A equals 238. What is A equal to? And then we're going to do the same thing with our charge, number of protons. So the element that we form is, darn it, I just drew a blank on what element that is. TH. Let's pause here. Look it up. Go to your periodic table. Dun, dun, dun. I was about to make up a whole, and I'm not even going to tell you all what I was going to make up. So I'm glad I fact checked myself. Thorium. So we see, right, how uranium 238 literally changes identity and turns into thorium 234 via alpha decay. Let's look at a second example. So this says the reaction of an alpha particle with magnesium 25 produces a proton and a nuclide of another element. Identify the new nuclide produced. Woo! Okay. There's a lot of language in this example here. So I want to pause here to make sure we understand what we're being asked to do. So we're writing a nuclear reaction, and the reactant is an alpha particle with plus magnesium 25. Produces means it's going to be a product, a proton, and a nuclide of another element. So we're like, okay, what is that other element? This is what we're trying to figure out. You can think of it, if the math resonates, it's almost like this is what we're solving for, right? Or we could say, as a result of this nuclear reaction of magnesium 25, what new element arises from magnesium 25? Okay, so here is our reaction. We've got magnesium 25. This is our nuclide, right? Our notation for it. It reacts with an alpha particle. This is our alpha particle. And they tell us it forms a proton and a nuclide of another element, which is unknown. And they're saying, what is that unknown? So this is what we are solving for. We want to know what nuclide is produced. So we're going to balance our mass number and protons. So this really becomes a math problem, right? 29 over here, 1 plus what is going to give you 29? So our new element is aluminum. aluminum. Okay, so I'm actually going to pause here. I want you to I want you to take a moment and soak up, better yet, draw. What is a nuclear reaction? Or just however you want to summarize it. Write it in a sentence. Write it in a phrase. Write 3 words that come to mind when you hear nuclear reactions. But just take a moment to allow what you just listened to integrate. And I'm saying it now, and also try this method as you move through the rest of the lecture videos. See you in the next one.